Let's do lab 6 now, and then on Wednesday we'll go over the results of the quiz. Okay, and then we'll carefully go through each problem, and I'll try to help you understand what you need to do mentally in the next quiz to get 100%. You need to, for sure, you're going to need to practice more than you're practicing now. I mean, a lot of you are doing great, okay, but there's a lot of you that it doesn't look like you're practicing. Or if you are practicing, you're not practicing effectively. It's just have to change your strategy about how to prepare for the next quiz. Okay, let's do the lab 6. And I want to show everybody that I did modify lab 6. And what I did was I dropped exercise 2 because it wasn't that good of an exercise. And we did modify exercise 1 in lecture last time. We made it easier to port over your earlier work and just reformat it as a class, using a class. And so that ties in. We've got one problem that we've now seen 3 times. The first time we saw it where all the code was in main. This has to do with generating the web page with the random values in it, random colors. And we've seen how to do that using a function, in main rather. And then we looked at creating exactly the same behavior, the same output, but using a function to simplify the coding. And then the third view, or the third version of our solution, is a solution that uses classes and objects. Well, it uses one class, in this case the web page class. And that web page class has got these 3 functions, but it has no state in it. So it's not a great example, but it does show how to reorganize our previous work. And so what I did was I took the old assignment 2 and moved it into to this lab 6, and then took last quarter's quiz 2 word for word without changing it, and I'm making that assignment 2. So your assignment 2 will be to do the quiz that I gave last quarter. All right, but today what we're going to do is exercise 2 and hopefully exercise 3 of lab 6. So let's go ahead and get logged in here. All right, so we have lab 062. Did we look at that last time? I think we started that, but we didn't get anywhere. There's nothing there. Okay. All right, so we're going to need a main function. Well, let's get it from somewhere else. So we want to have web page as a header. We'll have something else, and it'll look like something like this. There we go. I'm just going to comment that out. And let's just check our environment. Can we build that stub of a main function? Okay, so that's working. And let's go ahead and take a look at this. The number class. Develop a class called number that represents an integer value. Right? What we did last time, we developed a class that represented a web page. Now we're going to develop a class that represents an integer value. The name of the class is number. Last time the name of the class was web page. The class should have a constructor that takes the integer value as its only argument. The constructor should store this value in a private member variable. Define public member function is prime that takes no arguments and returns a bool. If the number is a prime number, then is prime returns true, and so on. So let's here's the test code to use. So we need to create a class, but I want to focus on this part of it, that we need a constructor. So the number class has a function inside of it called number. Let's do that. So I'll have a header file. I think what I'm going to do here, I'm going to show an alternative procedure. Actually, what did I ask for in the lab? Oh, here. Your solution to this exercise should have these 3 files. We could put everything in one file, but I'm asking for the code to be spread out in these 3 files. And this is typically how you would organize a program. Of course, you would normally have many classes, not just one. So let's go ahead and do that. So number.h. This has got the class definition in it. And we talked about this last time, that just in case we include the file and we cause a circular inclusions, that we want to break that looping, and we do it using these what are called compiler directives. So we put the code, we put the header file inside this if endef number h endif. So this means if not defined. If this symbol is not defined, then go ahead and include the code that's in here. Otherwise, skip over this, skip to the endif section, so you don't include anything in there. And if number h is not defined and we enter into this block, then we want to immediately define that symbol so we don't re-enter the block again. Here's the class definition. And there's a minimal declaration. So we can include the class like that. And we can, I don't think we need this. We can create an instance so we'll have tests in here, and we'll print all tests passed. Oops. This should be \n. We'll run the test. Here the test is just invoking the constructor for the class. So we have the data type here, number. So this is a user-defined data type. And the variable that is for which memory is allocated and the memory is then initialized by the constructor. That's called a number here. This is with a lowercase n, uppercase N here. So that's a convention I'm going to follow. It's a typical convention. Class names start with an uppercase letter, and instance names, an instance of the class, starts with a lowercase number. Let's see if that builds. That's okay. Now what happened here was the compiler generated a it didn't see a definition of a constructor, so the compiler generated a default version for the constructor. The constructor will normally look like this. Here we're not taking any arguments, and we won't do anything here. So that works, no problem. But actually, what we're asked to do here is that the constructor should take an integer value as its only argument. So we have a constructor that takes no argument. What we want to do is pass data in. So when we construct an instance of the number class, we want that instance to store this integer value. So our class, you can call it a wrapper class. It's a wrapper around an integer. So here we pass in an argument to the constructor, say n, and we'll need to store that. And this will be the typical way to do that, although there are other ways of doing it. We declare the member variable in a private section, so we make that member variable private. That means only code inside the class, only functions in the class can access n. This n. So this n is restricted. Code that's not in a member function from number can't get at n. This n here is even more restricted. This is local just to the constructor. So we need a way to distinguish between that local n and the n that's part of the class. And so we use this. So we use this arrow n, and that means the n that's a member variable in the number class instance. And this n here, which is not prefixed by this arrow, that's that more locally scoped n that's being passed into the constructor. This n here, that's the argument to the constructor. All right. Now there's a flaw in this. Oh, well, this is a different flaw. Does anyone know the problem? Here, the best way to read this, let me show you how to read this, okay? Start at the top. And so this is where we have the instruction to compile. And then it says, okay, main.cpp gives us the file, all right? There's a problem in that file. So there we go. That's a piece of information. And then it says in function int main. Okay, the problem, it's in that file, main.cpp, and inside that file, there's a problem inside that main function. All right, that's all we can get from the first line, but there we have, that's how you read the first line. Now the second line, it repeats the file name, then it has an 8 here, that means line 8. So the problem, the compiler is reporting a problem on line 8. It might not be on line 8 actually, but that's where it thinks there's a problem. And that's where the compiler stops and decides that I can't go any further, something is wrong. And it also tells us the column number, so character number 11 in line 8. That's where it realized that something was wrong and it failed to continue. And here's the error message. No matching function for call to number. Remember the a hat is like a quotes. So number colon number and then parentheses. You're gonna?
I think that means it's missing a constructor.
Yeah, actually that is a constructor. But that particular constructor is not defined. This is like see number, see the colon, the number colon, that's the class name. So the class name number is preceding the function name, which is also number. Remember, a constructor has the same name as its class. So if this were a function called like init, then this would be number colon init. That means init is the function in the class. But here, it's the constructor, the code that runs when you create an instance of that class. So it's saying that you are trying to invoke, in your code, in line 8, you're trying to invoke the number constructor, one that takes no arguments. This is line 8. You can see down here, in my tool that I use, I can see that's line 8. If I look, I'm going to go over, that's line 8, character position 11. But to tell you the truth, the character position doesn't really have a lot of information, for me anyway. I usually ignore that. I just look at the line number. So this constructor here that we're invoking, by the way, in most languages, this would look like that. But in C++, that's they had some issue with making the language compatible with C, and so they couldn't define a constructor like this. I think that's the story, but whatever it is, most languages would show this as the invocation of the number constructor. But in C++, it's an exception. But so here we're invoking the constructor that takes no arguments, but we have not defined that. We've defined a constructor that takes an integer. So the compiler says, I can't find it. I can't find what you want. No matching function for call to this. That's what we're invoking. And the compiler is saying, I can't find that. So actually, our issue there is we need to pass in a number. So we have a constructor that's defined that takes a single integer value. Let's try to build that one now. There it goes. No problem. That's that issue. Now, the other problem here is that, well, this is actually, we're going to have trouble if we try to include this in more than one place. So generally, well, actually, this will be okay. I said, this is fine. We can do this like that.
Does that one have to be in the same lab folder that we're making this episode?
Yeah, the 6, yeah, they're all together. Let me show that to you. There's main.cpp, number.h.
So the one you're missing is the number.cpp.
Exactly. So let's go ahead and create that. Now the number.cpp contains the implementations of the functions. Let's see, this is include number.h. So what we'll do here is provide an implementation of the constructor. But there's a problem here because we're providing two different implementations of the constructor. So that's going to fail. Let's take a look at what that looks like. And by the way, this is not good enough. Now we have another file with an implementation in it, so we need to pass that in on the, we have to tell the compiler to go ahead and compile both of these compilation units. That's what they're called, two separate compilation units. Look at this, redefinition of the constructor. I mean, there's too many definitions. So we're going to take it, we're going to leave it in the CPP file, and we're going to take it out of this one. This is the typical organization. So I'm showing you just the typical organization, although there are exceptions. You can organize the code differently. Let's see if that fixes the problem. Yeah, that got it. All right. So there's the constructor. This is what we've done here. And also we want to include a UML class diagram within a multi-line comment in number.h. So I want to do that. And just to make it easier, I'm going to copy this. Here it is. No, that's not it. Let's put this this multi-line comment here. And it's not web page, it will be number. So we have a constructor that takes an integer value, put it like this. This is what we have so far. That's what we currently have. We have a public constructor. Oh no, that's not what we have. We have a member variable. And the member variable is private, and generally it will always be private. And it's called n, and it's of type int. Is that how I'm doing that? Yeah. So there is the UML class diagram. There are other diagrams in the UML specification, but this the diagram type that we're going to look at is the UML class diagram. And the top region is the class name, that's number. The middle region here is a list of member variables. This holds the state of instances of the class. So we have a member variable n, which is private. And the third section is a list of functions that are in the class. We have only one function right now, and that's called, which is a special function called a constructor. It doesn't have a return value. Let's just check to make sure that still builds. Okay, good. And we have some, define a public member function called isPrime that takes no argument and returns a bool. Oh, we can do that without reading what it does, okay? So this will read next. We can just go ahead and represent that to see what that's going to look like. A member function called isPrime that takes no argument but returns a bool. Oops. So it takes no argument, but it returns a bool. In UML, the syntax is different than like the C++ syntax. Here, the data type is listed after the function. The data type of the function is return value. The data type of the identifier here, it follows that identifier. It doesn't precede it like we do in C++. It looks a little crowded to me. Does that look better? Whatever we do, we just want to be consistent. Does that look better? Both versions look bad, right? Okay, so we have a function isPrime and it returns a bool. So let's declare it. We'll declare it here. Now, this will actually build. No problem. And it runs. No problem. But if we were to, now 7 is a prime number. And that's what that is prime function should do. So is prime should return true. So we take a number and we do is prime. That should return true. So this assertion should succeed. But actually, this function call won't compile. We'll need that CAssert header. That CAssert has the definition for the assert function. So this number instance, and I'm going to change the name. I'm going to call it 7. Well, that's what it is. This number 7 is in fact prime. So when we call the is prime function, we want it to return true, because 7 is prime. But now we did not provide an implementation of is prime. We declared it, and we were able to build the code. But now that we actually try to use the function, we get a linkage error. See this LD right there? This is that's the program that tries to link what are called the object modules or the object files. So the main.cpp that produces main.o, and it has the machine instructions and some other information in there that is used by the linker. And then you've got number.cpp ends up generating number.o, which has the machine instructions to implement the functions in the number class. And when the linker goes to try to say, oh, because in main.o we've got code in there that's trying to call into the is prime function, but the linker can't. It's breaking down there. The linker can't find is prime in that number.o file, so it's failing there. Undefined reference to. Okay, you'll see there's a .o file here. It looks like it's using the temp folder, and it's generating an object file in there like that. That's probably where it's storing its compiled version of main. And it's trying to link this with the other object file that should have the implementation of is prime in it. Anyway, let's go ahead and add that. Is prime returns a bool. It's a function in the number class. So we'll just return true. That's a stub. This time it builds all the way. All tests passed. Now in the test first strategy, what we're going to do is build our tests before we implement the functions. That's called a test first strategy. So if let's create another number called 9, and 9 should not be prime. So if we call is prime on our 9 object, which encapsulates the value 9, that should return false, because 9 is divisible by 3. So we write the test code first, and we know in advance that line will fail. We're just checking our test code. So we want to see that this assertion here fails. Line number, look at this, line number 13, assert not 9 is prime. Let's see if that fails for us, as it should. There it is. There's the line 13. Assertion not 9 is prime failed. All right, good. So we know the test code is looking good. But actually, what I did on this lab is I gave you all the test code here. So we can in fact just plug it in there. You don't need that see and get. That's just for people using Visual Studio. It's convenient to put that in there. This waits for the user to hit the enter key. So actually I'm giving you all of the test code. And there it is. And that didn't come out very nicely. Let's read through the test code. That sounds pretty boring, right? Let's read through the test code. Okay. All right. So we create an instance of the number class here, and we call the instance 9. We pass in the integer 9. So now we have an instance of our number data type that represents 9. If we call is prime, that should return false. So we want to negate the false and make it true and pass the true to assert. So we can pass that test. Oh, here's a function we didn't talk about yet. We need to define a function called is divisible by. And 9 is divisible by 1, and therefore this function call here should return true. 9 is not divisible by 2, so when we call is divisible by 2 here, we want to negate the return value to convert the false into a true and then pass that to assert. So the first thing we'll do, let's just get it to compile, and then we'll put the logic in after we can get it to build. And we want to see the test code fail with our stubs. Oops. Is divisible by, and this will take, say like K. And this returns a bool. There that is. And let's go ahead and get that implemented. And we're going to always return true here. All right, once again, what we're trying to do is I'm going to save all my files. What we're trying to do is just get this to build. There we go. It builds. Now we should see it fail. Let's predict, before we just run it, let's do some prediction. So we have some sense of control over what we're doing here. This is okay. That constructor works. And then is prime returns true. And so this should fail. So we should fail on line 10. There it is, line 10, assertion failed. Good. All right, so we've boiled it down to here. We need to implement this function is prime, and we need to implement the function is divisible by. So we've whittled the problem down to those two things. And actually so there's a lot of kind of coding and organization involved in just getting to the point where you're really figuring out the algorithm. I mean, now we need the algorithm to figure out how to implement is divisible by and is prime. So, you know, that's half the problem. Half the problem is coming up with the algorithm. The other half of the problem is how do you organize the code to make everything run? All right, so let's go back to here. Do I give any more information? So we're okay there now. All right, so we had a previous problem where we solved that problem is prime. We implemented as prime, right? Does anyone remember the lab number?
It's like lab 3, I think.
3-2, I think.
3-2? Whoops. All right, we'll try that. Let's try 3-2.
No, that's the feet to meters.
Give me another guess.
It's lab 1, I think.
Lab 1 is prime?
No, lab 3, exercise 1.
Oh. Oh, what about the one that has a function is prime? Didn't we move that into a function? Or not?
I meant 4-2.
4-2.
4-2.
Because we don't want to have to rip it out of main. We already have a function called is prime, so we're just going to use that. 4-2, you said?
Yes.
I think 4-2 gives you the numbers. Like if you enter 10, it'll give you all the prime numbers.
Yeah.
So I think it's 4-1.
4-1?
4-1.
No, didn't we have to?
The prime factors of a number provided by the user.
Yeah, but
You didn't do functions till after.
yeah, so is that,
So it'd have been
is it
5.
lab 5? There it is, 5-1, okay.
So we get progressive.
Yeah.
That's why we did so well.
Well, I mean, that's, yeah, right. That's, of course, so here's the, there it is right there. So, you know, I mean, this is it. That's it right there. Just paste that right in there. Now, oh look, an n. We picked the right variable, n. That's our member variable, so we don't have to change that. So there it is. We're all set there. So I'm not going to go through that algorithm again. We talked about that already. And so we should get through. In other words, this is going to return false now. So we'll fail here. Oh, wait a minute. This will return true. We're returning true. Our stub returns true. So we'll pass through this test. But here our stub returns true as well. This is where we'll fail because we're going to convert the true to a false because of this negation operator here. And then we'll stop here. So that's line 12. Let's take a look at that. We should fail on line 12. Well, the program's getting bigger. I'm just kidding. I don't know why that took so long. There it is. Sorry. Line 12. Assertion. 9 is not divisible by 2. That's our failure there. Okay. So now we need to implement that one. Did we do this yet? I don't think we didn't implement a function that does, but this is easy, right? Can you figure this out in your head really quickly? Do we need a loop? We don't need a loop. It's a one-liner. This is a one-liner. We put it right in the return. Who knows what to do? So is n divisible by k? How do we do that? Yeah, the remainder. We use the remainder. If the remainder is 0, then we return true. See that? We take n, divide by k, take the remainder. So this you can conceptually think of this as being replaced by the remainder after dividing k into n. And then compare the remainder to 0. If it equals 0, then this evaluates to true. And that's what we want to do. We want to return true. Look at how easy that one was. This should pass every test. Look at that. We're done. That went fast right at the end there. Isn't that nice? It just boiled it down to one line right at the end. It's not, oh, there's still a mountain of work left. We're going to have a loop within a loop. And no, it's just simple. Okay. Any questions about this one? I want to show people how to work with the repository a little bit, although we're running low on time here. I mean, normally I want to delete a dot out and then you know, commit everything to the repository. So I'm going to do, but let's suppose I forget to do that. Lab 06 2. So it should be svn add lab 06 2. Well, we could do it like this. Let's see if that does it there. But, whoops. We added a dot out, which may not be a problem, right? So you could just leave it in there if you like. But we did have some issues with that last quarter. So let's remove that. I'll do svn remove lab 06 2 a dot out. Oh, that doesn't work. That file has local modifications that are not in the repository. So svn is conservative and says, are you sure you want to do this? So yes, so we're going to use force. Exactly. We can put it onto the end here. There we go. So it's telling us that it deleted it. Now let's go ahead and commit. There we go. That's done.
But if you committed a dot out already, then there's no work.
You can still use remove and then after you issue the remove, then you commit. So the commit will actually remove it from the remote repository. Now we've got 3 to do, and I'm going to add that in there. Then I'm going to copy. Now I'll tell you, I don't want to copy the whole folder because I don't want to copy the .svn subfolder. Then I'm copying some other folder's .svn subfolder on top of the one we just created. See, when we went svn add lab 063, that command created that .svn subfolder. And I don't want to have to. I don't want. That's going to create a lot of problems for us if I try to copy all of the contents of 02. So let's just copy the CPP files first, and then the header files. And there's only one. Sam, what happened there? You're kidding. All right. Okay. So I'm going to remove. What is the problem? Is it the number class? Listing primes with functions. Oh no. Let's go up to lab 6. Prime number web page. Create a class called prime number page. It generates web pages with lists of random prime numbers that are between 2 and 1,000. Include the following member functions in the prime number page class here. And here we're going to reuse our work here. that we've already done. All right, so let's grab that. I'm just going to do it this way. Oh, I can have that. Good. So I'm going to copy lab 062 into here. All right. So we'll have another header file here called prime number page. I think that's what we called it. Prime number page. And what this does is it generates web pages with lists of random prime numbers that are between 2 and 1000. And these, we want the constructor and a print function. Add a UML class diagram to show how this works. Okay, we're kind of running out of time. I can do this quickly. Is that all right? I just sort of speed through it. So show this to you. Okay.
Just watch it on the video.
All right. All right, here we go. I'm going to zip through this. Well, actually, this code we don't want. Yeah, we're not going to run any tests. We're just going to print some kind of a web page there. And in fact, let's grab that the web page. It's in was in lab 06_1. I need 2 dots there. So we're going to copy this to prime number page.h. See, that file is that's the most similar to what we're going to end up building. So I'm copying. That's the reason I'm copying that one. And then let's take a look at this header file. And this will work, but I think we should correct it. Prime number page h. And this is the prime number page. Try to center that up a little. Prime number page. There's a print, I know that. I think we don't have this. Is that what we have? Just a no argument constructor and a print function. Oh no, we pass in this integer here, number of primes. And then here's the print function. So there should be number of primes. And that's an int. And let's go ahead and change this. This is the prime number page here. This is an int called number of primes. And here's the print. And I think what we can do is store that in here. String, hex string. Generate hex string. I'm not sure how you can either we could generate everything inside the constructor and then just print it, or else we can store the n and then generate the prime numbers in the print function. And just to make things go faster, let's look at what we currently have and make the smallest possible change. So this is prime number dot CPP. Prime number page. This is the constructor, which needs fixing, and this is the print function. So we have the loop right inside the print function. We know that this loop here will have, n. That'll be the number of times we run, and this will take an int, number of primes, number of primes, oops, gotta fix that, and let's see, so we'll do something like this. Prime number page. We'll pass in 5. I'll just call it page. And then we're going to call the print function. That's our test, right? So let's see, what are we going to do now? Actually, the main function is done, so I'm just going to leave there. So we have prime number page. It takes this. We implemented that. We implemented this. But we want to add a member variable n here. And actually, that should, we call it n there, don't we? Let's call it number of primes. I think that's better. Let's do it like that. Oh yeah, that exactly. Two things I forgot there. So it's private, and we want to just tighten that up. That's done. And let's go over to here. Yeah, we got that one right already. Oh, so this n here, this should be number of primes. Oops. And I think we're getting there. So we just now here, actually this loop. Oh, generate hex string. We could change this. This is our how do we do that? Oh, let's forget that. We could do I'll do it this way. So running out of time here. I don't think I'm going to be able to finish. While I is less than the number of primes, So in here, so here we have a loop. And each time we print the prime, there we go. This is the list item. We print our prime number here. Oh, we'll call it a number. And then close that off. So that means we just have to generate the number. Maybe we'll finish. So this is the, we're going to create a number here. And so we're generating a number. And if the number is prime, I think we're going to finish. Oh, that won't work. So we generate a number here. If the number is prime, then we'll print it. And we'll increment I. That's the number of primes that we've already printed. So we're going to go into this loop here. Oh, but number takes a random number, right? It takes a number. So what we need to do is we need to generate a random value. So we're going to call rand. And then it had to be between two ranges, right? 0 to 1,000, something like that. Here we generate the random number. We're almost there. Oh, we got C standard live in there. Think it'll work now? Undefined reference to prime number page int. That's in main. Prime number page int. Oh, look at this. This doesn't go in here. Prime number page. This should be it right there, right? Oh, do you see the problem? We have to build that unit as well. There is no number of primes. We got to add that to the header file. So this here in the private section, number of primes. I think we're going to make it. I know we're going over, but it's going to build. Number was not declared in this scope. Prime number page. Number was not declared in this scope. Line 22, prime number page. If you're late, take off. I'm going to finish in 60 seconds, but if you're late, go ahead and take off. I'll finish recording this and post it. I forgot to include the header file. I'm going to get this done in 60 seconds. Oh my God. Oh yeah, that's going to be tough. All right. I'm going to get it. That's the number. Oh, V. Prime number page.
Nice.
Ah. That doesn't work. I got another class coming in here. I got to get out. Prime number page print. No match for operator with oh. That's an easy one, I think. The problem is here. This number, I need to have an accessor here. So we're going to do get value. We have to add that. This should be get value. Oh, we don't need that. We don't need that. We don't need that. We don't need that. What we do is we just we got to save that random number. Integer n, like this. We got to save the number. And then print that. That's one way to do it. So now we print the n. So we don't have to add a function. I mean, it would be nice to add a function though. All right, let's see if that works. It works. Hey, you're all here. Great, that's it.